Hi everyone. This is my second video. So this you can see is actually another set of problem which is typically very common when you deal with something at the level of physics Olympiad at 10 plus 2 level or even for IIT advanced as well. So what this problem states is actually there is a frame, a conducting frame as you can see, which is connected to a spring with a spring constant K, and this conducting plane is slightly immersed into a liquid. As you can see, there is a liquid into the beaker and then released. So the amount of depth it has been put into the liquid is Y, and there is also a magnetic field of induction, field of B, which is coming right normally out of this page, as you can see. And this whole system then automatically will create some kind of a motion, because when you release this, by and default, if this speaker is actually just containing a I would say incompressible incompressible and basically a homogeneous sort of a liquid, then it will conduct a simple harmonic motion. But in this case, because it's not a homogeneous, it's not exactly a simple liquid that is there, but the liquid is also having some kind of, is also kind of exposed to a magnetic field that will have an influence into this conducting frame. And moreover, this conducting frame is also having resistance, as you can see, R. So when you immerse this into a distance y, as can be seen, it will not exactly execute an SI chain, but it will execute a different sort of a equation or different sort of a motion. That motion is defined through this equation. Okay, and this motion, if we solve this is a differential equation, second order differential equation, as you can see. So this second order differential equation, if you solve, then this will come to some kind of a solution like this. But this is how basically, if you can see, and what this problem contains, this contains multiple things amalgamated in together. One is of course the spring, which ensures a spring in constant and the elasticity onto the frame, and this is a conducting frame, and when the conducting frame basically moves within the magnetic field, it creates an induction, electromagnetic induction. That induction will ultimately create a current within that frame, and because there is a resistance, that induction will create an EMF, induced EMF, and that EMF will in turn will create a current which will flow through this frame, and the current will try to oppose its motion. So if we are trying to pull it down, it will trying to push up. Okay, and that's how all this combination comes into picture, and then that's when this particular equation of motion is getting derived. So this is a very common sort of a problem. There are similar kind of problems that we normally expose or encounter in our day-to-day life, which are again sort of things which are put into a physics Olympiad or in advanced IIT. If you see, I have been compiling such problems. I have already shown one of them in my previous video. This is the next one. Similarly, I have been compiling many such problems which are mostly done by myself, and it is purely done by myself. It is not compiled from anywhere else, and there are already 9 or 10 such similar problems, which is slightly complex in nature, and it is actually involves in multiple theories and topics being amalgamated together in a single problem. So this is like a book, or you can say a sort of a booklet which I am preparing. If anyone is interested, they can connect me over YouTube. I can share that booklet also. But also, apart from that, as has been mentioned in my previous video, I do conduct such trainings, coachings, and it doesn't restrict here. I also actually, based on this, these are basic physics, as you can understand. Based on this physics, I go on to a bit more deep, like how you can deal with quantum computing. Now quantum computing is an area which is based on quantum physics. Most of the people know who are in this area, but if somebody doesn't know, it's the basic term is like anything which you deal with binary. Like, what is a digital computer? It deals with 0 and 1, so on and off. So that's how a binary computer works. It's a 0 two number system. But when you deal with a quantum computer, it's basically a multi-state system. When I say multi-state, it can have a 0 state, it can have a 1 state, and it can have an entangled state. because of quantum entanglement, and those are the things which comes from physics, which comes from quantum physics, and those are the basic building block of a quantum computer. So these are also something which I actually teach to give insight of what is going on, because if you see in today's arena or today's technology landscape, why we are going to learn all these things. So the reason is, all these things are the basic building block. If somebody says these are not required, that is not true. So these are the basic building blocks to go into quantum computing, to learn how you are going to do a very large scale integration of a circuit. Okay, because when you are going to build such nano components, such resistors, inductors, capacitors within a small area, that will have a lot of inductions among them, lot of coupling among them, that does cause a lot of problems, that does cause a lot of noise, and that noise is not what will cause a problem also, and you have to kind of avoid those noise. So these are things, these are not coming from just somebody who doesn't have a background or proper knowledge on proper basic physics, or strong on basic physics, or I would say even mathematics. It will be very superficial for them. Okay, so ultimately these are the things, these are the building blocks which, based on that, you whatever new fields that you see today, that includes AI, artificial intelligence, that includes quantum computing, that includes VLSI design, all are based on this. Well, somebody might say, why AI? Well, for AI also, if you see, AI is based on heuristic, it's a probability. So even quantum mechanics is also probability. It says like for where a particular atom would be in a particular state of point and space in time, which depends on multiple factors, and that's where from even AI comes in. So it doesn't give a accurate result always. It's based on a certain past decisions, past data points, and then based on heuristic, based on most accurate probability model, most accurate mathematical model, it realizes what the future could be. Or it can do some other things also. It can generate things also. Again, generation is again based on a huge volume of knowledge base. Based on that only it generates. But these are fields which are based on physics. Ultimately, at the end, whatever AI may be based on programming up to a large extent, but even that programming, when you are going to build that programming into those programs as part of giving an output, so that program has to ultimately be based on some platform, and that platform is what is actually coming out of this. Okay, I'll end my video here. So if you have any questions, concerns, you can give a comment into my YouTube channel, or if you are interested, you can just touch base on me. I'll revert back with my contact details. You can contact me.